For this lesson, we're going to be looking at multiplying 4-digit by 1-digit numbers. So we're looking at multiplying the thousands this time. You'll notice on page 77 in your SOB book that you can use a model to multiply greater numbers. We've been using those area models. But you can also make these into smaller rectangles to represent 1,000. Each of the columns represents 7 1,000s or 7,000. You can see the problem below. They did 7 times 3,000 equals 7 times 3 times 1,000, or 7 times 3 times 1,000. 7 times 3 we know is 21 times 1,000, so my answer is 21,000. Okay. I was using the distributive property. So go ahead and look at number 1. When multiplying by thousands, how many zeros can you expect in the product? Well, we know our place value when it comes to zeros, so we know that our answer is going to have at least 3 zeros. It can't have less than 3 because I already have 3 in my problem. So if you are multiplying by thousands and you get an answer that's less than 3 zeros in it, definitely need to relook at your problem. Okay. Go down to number 3 where it talks about drawing a model for 4 times 8,000. Then find the product. Well, we know we can draw an area model where we have 8,000 on the top and 4 on the side, but you can also think of 8,000 as 8,000 boxes. And keep drawing, and then I've got 3, 4, 5, 6, 7. So each one of these boxes represents 1,000. So if I were to multiply this, I have 4,000 in each box. So 4,000 plus 4,000 plus 4,000 plus 4,000. I'm going to do that 8 times, which will result in 8 times 4, which is 32. And I have to have on 3 zeros because that's how many I started with in my original problem. I kept going and wrote the rest of my thousands. So I can draw an area model like that. However, we've learned a quicker way to do it. So let's look at different methods again for multiplication. So I can multiply 4-digit by 1-digit. Doing the same methods I've done for 2-digit by 2-digit, 3-digit by 1-digit, and 2-digit by 1-digit as well. Okay, so remember, basic area model. If I have the problem 6,435 times 9. The beginning of this unit, you guys would have gone, oh no, I don't know how to do this. But you do know how to do this now. It's the same principle we've done for all the rest of the multiplication. So I'm going to draw my area model. Because I only have one number here, I only need to draw one box vertically. But I need to divide this into 1, 2, 3, 4 parts. I know that my 9 goes here, and then I'm going to decompose this number. So in expanded form, this would be 6,000 plus 400 plus 30 plus 5. And I'm going to take these numbers and write them at the top. 6,000, 400, 30, and 5. So that's my basic area model. Okay, I know that my little plus signs are in between. To take it a step further and use the place value sections method, remember I'm going to end up writing the equation inside each box. So I have 6,000 times 9 equals 6 times 9 is 54. How many zeros? 1, 2, 3. Add those back on for my place value. Okay, now I'm going to have 400 times 9 equals, I know 9 times 4 is 36. I have 2 zero place values, so I add those back on. In the third column, I have 30 times 9 equals, I know 9 times 3 is 27, and I have 1 zero to add. And in the last box, I have 9 times 5 equals 45. Remember, with these numbers, what I do is I'm going to add them now. So over here to the side, very carefully will I make sure that I line up and make sure that I copy the number exactly that I wrote in here. That's one big error that a lot of us make, is we don't copy down the number that we write down here over in our addition problem. So go ahead and double check and then triple check. Make sure you're writing down the correct numbers. So now I have 3,000, I'm lining up my commas, 600, 270, and 45. You're always welcome to use grid paper to do addition for big numbers like this, so that you can make sure that you use each column for the correct number. So here I have 0 plus 0 plus 0 plus 5, so that's 5. I have 0 plus 0, 7, and 4, which is 11. 6 plus 2 is 8, carry a 1 is 9. 4 plus 3 is 7, and my 5 drops down. So my answer is 57,915. If I take this even a step further and do my expanded notation, again I've got the same box. However, when I write this out for expanded, I'm going to have my equation 6,435 times 9. And remember, I'm going to decompose it now to the side of it. 6,000 plus 400 plus 30 plus 5. And then I have my 9 over here in the ones column. So my first step is to take my 9 times 6,000 equals. And I know that that equals 54,000. Then I'm going to take my 9 times 400. I know 9 times 4 is 36, and I have 2 zeros. My next problem is 9 times 30. I know 9 times 3 is 27. And I made a mistake. What did I forget? I have a 0, so my place value needs to be put on it. So 270. And then my last is 9 times 5. So notice how the 9 got distributed to each number. And 9 times 5 is 45. And I add them all together. 5, 11. See. Now I'm having a hard time seeing where my numbers are. 0 plus 6 plus 2, 8, 9. 4 plus 3 is 7. And my 5. I kind of tried to squeeze all that in there. So even I had to make sure that I had the correct numbers in the correct column. For the next one, we have that algebraic notation. Same concept with that area model that we did at the very top. However, this time when I'm writing it out, you're going to see me write 9 times, remember that dot means times, 6,435 equals, and that 9 is going to get distributed to each value in this number. So it's 9 times, and then in the parentheses I'm going to decompose that number again. 6,000 plus 400 plus 30 plus 5 in parentheses. And then remember the distributive property says I'm going to take this number and I'm going to distribute it to each number and multiply. So if I have 9 times 6,000. In between each one is a plus sign. Parentheses 9 times 400. In parentheses plus 9 times 30. In parentheses plus 9 times 5. My next step is to find my answer for each one of them. I know 9 times 6 is 54. I have 3 zeros. Plus 9 times 4 is 36. 2 zeros. Plus 9 times 3 is 27. Add my 0. Plus, and 9 times 5 is 45. So now I'm going to turn these vertically over to the side and kind of just do some scratch work. 54,000, 3,600, 270, 45. So notice I'm not writing on the lines because this is kind of just my little chicken scratch over here to make sure that I'm adding it up correctly. 5, 11, 9, 7, 5. So this equals 57,915. So again, you're noticing the same concept with each method that we've already done before.